So today's math lesson is going to be modeling two-digit multiplication. What is this model called right here? What is this type of model that we see right here? What is it called? Mason?
An array.
Not an array. Carla?
Area model.
An area model. Now area models, when we use them, they're really easy. Because all we do is we break up the factor into its expanded form, and then we just solve using basic facts and patterns and addition. Well, we're going to do the same thing today. We're just going to add another two-digit number. Before we did one digit times two digits. Today, we're going to be doing two digit times two digits. But let's quickly review how to do an area model. When we use area models, what property are we doing? What property of multiplication are we doing when we have area models? Victoria?
Distributive.
The distributive property. Because remember, distributive property means you multiply by the values of each digit and then add them together. So, we've used it to find the product of a two-digit and a one-digit number. So let's look. 3 times 11. Well, the first thing we do is we break our larger factor, our two-digit factor, into its expanded form. Without looking at the book, what does 11 look like in expanded form? Colin?
10 plus 1.
10 plus 1. Then we take our 1, so we have 3 times 11, which is the same as 3 times 10 plus 1. Then we take our one-digit factor and we multiply it by both pieces of that two-digit factor. So we have 3 times 10 plus 3 times 1. Class, 3 times 10.
30.
30.
Class, 3 times 1.
3.
3.
So now we have 30 plus 3, because 3 times 10 is 30. We add it to the product of 3 times 1, which is 3. So class, 30 plus 3 is
33.
33. Well, we can do this same strategy with double-digit multiplication. We just have to add some extra steps. We're not really changing anything. We're just adding some extra steps. So, let's go ahead and look at the draw it, which is basically example. Okay, so on the draw it, which in modeling lessons is the same as example 1, we have a grid model. A grid model is another type of area model. It can also be considered an array. An area model that looks like the one we did before we started would not be an array. But this one, because we have objects, boxes, in columns and rows, could also be called an array. But it's also a type of area model because we have all these connected flat sides. So, we're finding 12 times 15. So, step 1, we're going to label. We're not even going to solve. We're just starting out by labeling. So, I need to know which number goes at the top. So what am I going to count to figure out what goes at the top? What am I going to count to figure out what number goes at the top? Zari.
The rows.
The rows?
The columns.
The columns. Remember. Zari, please turn your camera on. Remember, rows are like bushes. Can you plant the seeds for the bushes right on top of each other? No, because then only one's going to grow, only the top one. Columns, so rows go side to side because you plant the bushes next to each other, not on top of each other. Columns go up and down because think of columns on a building. They're used to help hold the roof up, so they have to be up and down. If they're sideways, are they going to hold the roof up? No. Are they even going to touch the roof? No. So that's how we know that columns go up and down. So yes, to figure out what number goes on the top, we have to count the columns. Zari, how many columns are there?
12.
Not 12. Let's count them, everybody together, but point to yours. Just stay with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So Zari, how many columns are there?
15 columns.
15. Remember, when we're counting the columns, we're counting the top object in each column. If we count these, well, we're only counting the number of objects in a column, not the number of columns. To count the column, you have to count the top object in each one. That's how you know how many columns there are. I know you think you may be counting a column by doing this, by counting the number of columns, but you're not. If you're counting these, you're just counting the number of objects in a column, not the number of columns. If you count these, you're counting the first object in each row. If you count the first object in each row, that's how many objects, that's how many rows there are. So if you're counting columns, you have to count across the top, like this. If you're counting rows, you have to count along the side, like this. So, to find the number on the side, we have to count what? To find the number that goes here on the side, we have to count what? Smith.
We have to count the rows.
We have to count the rows. Now, am I going to do this to count the rows, Smith? 1, 2, 3, 4, 5, 6, 7, whatever?
No.
No, because that's just counting the number of objects in a row. I want to find out how many rows there are, so I have to count the first object in each row. So, Smith, how many rows are there?
12.
12. So here's our area model. We have 15 columns. Let's label this as columns so that when you're going back to study, you remember. Because when we count 15, we're counting basically like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And when we count rows, we're basically doing this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Does everybody see how it's quicker to just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But it's the same thing. It means the same thing. It's just quicker to do that. Okay. So that just tells us, oh, and this is rows. Let's label that. So that just tells us, this is just showing us how to draw an area model, a grid area model, for 12 times 15. But did that solve it? No, that's just the first step to a grid model. However, we're not going to do grid models once we get to the actual independent practice and homework, but this helps you to actually see it, because this is exactly how much, if we count each of these individual squares, that's exactly how much 15 times 12 is. But let's move on to step 2 on page 294 to figure out what we do next. We just figured out how many columns and how many rows we have. Now let's see what we do next. Okay, so everybody, let's look at step 2. What we're going to do, just like with all area models, is we're going to separate the tens and ones of one factor, and then we're going to label it. So, we started with the number at the top. What was the number at the top? Mason? 15. So we're going to separate the tens and the ones, which means we're going to write in what form? We're going to write 15 in what form if we're separating the 10s and the 1s? Michaela? Expanded form. So 15 in expanded form is what? Zadie?
10 plus 5.
10 plus 5. So we have 10 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 5 columns. 1, 2, 3, 4, 5. All together, they make how many columns, class?
15.
15.
So we rewrote 15 as 10 and 5. So now, what we have is 12 times 10 plus 5. So what this looks like is 12 times 10 plus 12 times 5. This means this. They mean the same thing, okay? I know this looks weird because we haven't really seen it this way before, but it means the same exact thing. Because when you have 2 times in front of parentheses, it means you have to do, 12 times in front of parentheses, it means you have to do 12 times 10 and 12 times 5. So we leave 12 at the side. Let me see something really quick. When we get to the guided practice, I'm going to break this down even more for you. We're going to break it down even more. But for now, we'll do it this way. Because now we have basic facts, right? 12 times 10 is a basic fact. 12 times 5 is a basic fact. So step 3 is we have to find the product of each part. We have the 10s and we have the 1s. So we know 12 times 10 plus 5 is the same thing as 12 times 10 plus 12 times 5. So now we just need to solve. 12 times 10 is what, class?
120.
Thank you, Zari.
120.
Thank you, Zari, for knowing your basic facts. 12 times 5 is what, class?
60.
60.
Thank you, Zadie and Zari, for knowing your basic facts. So, we know 12 times 10 is 120 and 12 times 5 is 60. Can we just leave it like that? Is our answer 120 and 60? No, because what we have to do is then we have to add. So 12 times 10 we know is 120. 12 times 5 we know is 60. So now we just need to add 120 plus 60. Who can help me out with 120 plus 60? Kingston, do we need to set this up and down? Are we going to have to regroup anywhere? No. So let's add the ones. 0 plus 0. Add the 10s, 2 plus 6.
8.
Add the hundredths, 1 plus nothing.
1.
So that means 12 times 15 is what, Kingston? 180. So that's how we solve. Let's look at the talk about it. Then we're going to get to the independent practice, and we're going to break it down even more to make it so all you have to do today are basic facts and patterns. Because right here we do have basic facts, but what if this number was greater than 12? Would we have basic facts here anymore? No. We do know how to solve because 12 times a double-digit number times a multiple of 10, we know how to solve that now, right? But to make it even easier, we can actually break it down even more. But let's look at the talk about it for right now. Okay, so number 1 on the talk about it says, how would you use the distributive property to find 12 times 18? Then find the product. So basically what you're doing is steps 1, 2, and 3, but in words. So how could you write that in words? Or you don't have to do step 1 because you don't have to tell us how to draw the model. Just tell us what we did in words. Victoria, what was the first thing we did in step 2? because step 1 is just how to draw the model. Well, this isn't asking us how to draw the model. It's just telling us how would we solve this. So what was the first thing we did in step 2?
We broke down the bigger factor.
Well, we broke down, not necessarily the bigger, we have 2 double-digit numbers. So we just broke down
The factor.
one of the factors. In 12 times 18, which one should we break into its expanded form? 18, because then we'll have 2 basic facts to solve, right? So first, we break 18 into expanded form, which is what?
10 plus 8.
10 plus what? What'd you say?
10 plus 8.
Oh, 10 plus 8. I thought you said 10 plus 18. So we break 18 into expanded form, which is 10 plus 8. Then what did we do?
Then we take 12 and we multiply by 8.
Good. So then we multiply 12 and 10. Let's not say 12 and 10. Let's say we multiply 12 by 10 and 12 by 8. Then what? After we multiply and we find those answers, then what do we do?
Then we add them together and we get out.
We add what together?
We add
12.
we add 100 and
Well, tell me the math word that tells us what do we do. Do we add 12 plus 10 plus 12 plus 8? No. We add the, once we find 12 times 10, we're going to have a what?
we're going to add
Who can help her out? Once we multiply 12 by 10 and 12 by 8, we are going to have 2 what? Carla?
Answer that we need.
What? Not answers, because answers could mean anything. Cullen?
product.
Products. Come on, guys. Vocab, vocab, vocab. So, using the correct vocab, what do we do next?
We add the products together.
Then add the products. Okay. Are we done answering number 1, Victoria? No. Why are we not done yet?
Because we have to get the product.
We have to get the product. So, right here, let's do 12 times 10, which equals what, Victoria?
12 times it equals 120.
And then 12 times 8 equals
96.
96. Then we add 120 plus 96. Uh-oh, can we solve that sideways?
No.
No, because we're going to have to regroup. So let's just go right here to the side and write it up and down. Okay, Victoria, 0 plus 6,
6.
2 plus 9.
11.
Regroup the 1 to the hundredths place. 1 plus nothing,
1.
plus 1. So 120 plus 96 is
206.
216, which means 12 times 18 is
206.
216. Very good. Number 2. We're doing the same thing. So do we have to change any of the words from number 1? No, we only have to change the what? Michaela? The factor, just the numbers. We only have to change the numbers. So, who can help me out with number 2? I'll pick a stick because everybody should be able to do this at this point. Mason, all we're doing is number 2. But like Michaela just told us, we don't have to change any of the words. We only have to change the numbers. So, the first step to solve 14 by 7 times 17 is what?
Is it 17 now?
We're going to use the same exact words. So we're going to break 17. We're using the same words.
10 plus 7.
Look, Mason. We're rewriting. Look at number 1. We are writing the exact same thing, just instead of writing 18, we're changing it to 17. And instead of writing 12, we're going to write 14. So, let's rewrite exactly what this says, but replace it with the correct numbers. So, break 17 into expanded form. The reason we're doing that is because math is all about patterns. We have a different problem, but we're solving it the exact same way. That's why we are using the same words. So what comes next, Mason? In number 1, we had 10 plus 8 in parentheses. Are we going to have the same thing here? No, because those are numbers. So instead of 10 plus 8, what should I have?
10 plus 7.
10 plus 7. Now, what comes next?
Multiply 14 by 10.
Multiply 14 by 10. What comes next?
And 14 by 8.
Would it be 14 by 8?
14 times
We have 12 by 8. Are we going to have 14 by 8 here? So in number 1, we have our other factor, which is 12, the one we did not break down, and then the ones in the other factor.
8.
14 by 7. Okay? What comes next?
Then add the product.
Then add the products. So, are we done?
No.
No, because what does it tell us to do after we say how we would use the distributive property? In the question for number 2, or the problem, after we tell how to use the distributive property, what do we have to do?
14 times 6.
So, what does it tell us to do?
Then find the product.
We have to find it. So, first we have to do, just like up here where first we did 12 times 10, we have to do 14 times 10. Well, 14 times 10, we can tell right away is going to be what? Remember? Cover up the 0, and what do we have?
140.
Cover up the 0, and what do we have?
14.
We're only covering up the 0. What do we have? What do we have left?
1.
Look at the whole problem. Come on, this is like yesterday. Cover up the 0. Use your finger to cover up the 0. What do you have left? Only the 0 in 14 times 10. Make sure that you're writing with us. Michaela, what do we have left? If you use your finger, I want to see you use your finger. What do we have left? 14 times 1. Mason, what's 14 times 1? We know that right away. We don't even have to set it up. 14. Are we done? Is 14 times 10 14? No, because we have to remember that 0. Where does that 0 go? At the end of our product. So 14 times 10 is what? 140. Remember, anytime you multiply anything by 10, rewrite the number and put a 0 at the end. Now that's by 10, not a multiple of 10. anytime you multiply any number in the world times 10, the number 10, you just rewrite the number and put a 0 at the end. Because of what we learned yesterday. We know if we had 256 times 10, well, we know we're going to have a 0 at the end. Cover up the 0, you have 256 times 1. 256 times 1 is 256. So anytime you multiply by 10, not a multiple of 10, but by 10, just rewrite the number you're multiplying and put a 0 at the end. That's all you have to do. If it's anything other than 10, well then it changes. Okay, so 14 times 10 is 140. Well, what do we have to solve next, Mason?
Um, 14 times 7.
14 times 7. Now, is that a basic fact, Mason? It is?
No.
Our basic facts end at what number? Who can help them out? Basic facts end at what number? Kingston?
12.
12. Above 12, it's not a basic fact anymore. So what do we have to do if it's not a basic fact? Solve it up and down. 14 times 7. So we know, step 1, solve the ones. 4 times 7 is what, Mason? 28. Keep the 8 in the ones place, regroup the 2 to the tens place. Now we multiply the 10. 7 times 1 is what?
7.
Plus 2 is 9. So that means 14 times 7 is 98. Are we done?
No.
Is our answer 140 and 98? No. Because what do we have to do next? What's the last step to doing distributive property?
Add 140 plus 98.
Add the product. So 140 plus 98. Can we solve that sideways? No, we're going to have to do some regrouping. So let's go over here. And let's set it up and down. 140 plus 98. Remember, make sure that you are setting things up neatly so that you don't accidentally add or multiply the wrong digits in the wrong place. So Mason, add them also. Make sure when you're adding that you're adding, and when you're multiplying, you're multiplying. At this point, we get into some things where some kids do both in one problem. Like they may add 0 plus 8, which is what, Mason? 8. They may add in the ones place, but then they get to the tens place, and just because they know multiplication and they're going too fast, they multiply. 4 times 9 is 36. But is that what the problem is telling us to do? That's going to give us a super wrong answer. So 4 plus 9 is what, Mason? 13. Keep the 3 in the tens place, regroup the 1 to the hundredths place. Now add the hundredths. Don't multiply 9 times 1. We're adding 1 plus nothing, which is
1.
plus our regroup 1, 2. So that means 140 plus 98 is what, Mason? 238. Which means that 14 times 17, times 17 is 238. I actually decided we're not going to break it down anymore because you guys need practice with this multiplication. So we're not going to break it down anymore. But we will do 1 or 2 of the guided practice, of the independent practice together. So we'll definitely do let's definitely do number 4, actually. And then you'll go back. We're only going to do 1 of the independent practice together. We're going to do number 4. And then, so that I can show you exactly how to do it for all these problems, then you'll do the rest on your own. Okay. Okay, so the directions for numbers 3 through 6 tell us draw an area model, then use the distributive property to find each product. Now we're not drawing an area model like what was in the draw it because we're not going to do grids. We're going to do an area model like what we did in chapter 4. So first step we know is to draw a big rectangle. Second step is to break it into 2 pieces. Third step, because this is is just a little easier is to write the smaller factor on the side. So 47 and 19, Zari, which factor is smaller? Which factor should we write on the side, 47 or 19? 19. Which means at the top, we write our other factor, 47, in expanded form. So Zari, what is 47 in expanded form?
40 plus 7.
So we write 40 above the larger piece, plus above where it splits, and 7 above the smaller piece. So now we know we're not doing 47 times 19 anymore. We're doing, oh, they did it backwards but I like to take the smaller one. So just using your pencil, cross this out and write 19 times, oh, you know what? I see what they're doing. Let's back it up. Leave your box, but erase that. Because if we break the smaller number down, it's going to make it easier. It's really not. But whatever. Let's just do it this way, and then you can choose. When you get to number 5, 6, and so on, you can choose which number you want to put on the side and which one you want to break down. But in this case, they left our larger factor, 47, and they broke down our smaller factor. So that means we're going to write 47 on the side, and we're going to break up 19 at the top. Zari, what is 19 in expanded form?
10 plus 9.
10 plus 9. So we have our 10 above the 10th place, and we have our 9 above the 1st place. So now we know we're solving 47 times what, Zari?
10.
Plus 47 times
9.
9. Now we just need to solve. Well, Zari, 47 times 10. We know how to solve that without having to put it up and down. Because we know what digit is going to go in the ones place?
A 0.
A 0. And then we only have to solve 47 times 1, which is?
47.
47. So Zari, 47 times 10 is?
47. 470.
470. Watch out, because that'll happen a lot. It is a silly mistake that you can catch, but if you're going too fast, are you going to catch those silly mistakes before it's too late? Nope. Okay, now, Zari, we have to do 47 times 9. Do we know how to solve that yet? I mean,
No.
I'm sorry, we know how to solve it, but is it a basic fact?
No.
Definitely not. So, right here, let's solve it up and down. Zari, 7 times 9 is what?
63.
63. So we put a 3 in the ones place, regroup the 6 to the tens place. Now we multiply the 10. Zari, 9 times 4 is what?
36.
Then we add the regroup number. 36 plus 6 is?
42.
42. So that means 47 times 9 is what, Zari?
423.
423. Now what do we do, Zari?
We add 470 plus 423.
Now are we going to have to do any regrouping anywhere?
No.
No, so we can just solve side to side. So, add the ones place. 0 plus 3, Zari?
Is 3.
Add the tens place. 7 plus 2 is?
9.
Add the hundreds place. 4 plus 4 is?
8.
Which means that 47 times 19 equals what?
893.
893. let's actually do number 3 together again because it's right here, and I think we just need a little more practice. We're going to do some more practice with this tomorrow before we get into just multiplying pencil and paper, okay? We're going to break it down even more tomorrow, I've decided, officially. Okay, and then next year I think I'm going to flip-flop them, where we break it down even more the first day, and then we do this lesson the second day. But it's really too late to do that now. So, number 3, find 36 plus 24. Well, Kingston, we have to draw an area model. So what is step 1 when we're drawing an area model? Draw a big rectangle. Then step 2, or continue with step 1. What do we do next? We break it into 2 pieces. Now what?
Separate the tens and ones of one. Separate the tens and ones of one factor.
So then we'll separate the tens and ones of one factor. When we're doing double-digit multiplication, you get to choose which factor you want to separate. In this case, which one did our book separate? Did they separate 36 or 24? 24. And 24 in expanded form is 20 plus 4. Which means what the other factor goes on the side. So what goes on the side? 36. Now we have to solve. We know we have 36 times 20 and 36 times 4. Now 36 times 20. We automatically know what is going to go in the ones place. Who can help them out? Anytime we multiply by a multiple of 10, what goes in the ones place, Mason? A 0. Remember, guys, anytime we multiply by a multiple of 10, 20 is a multiple of 10 because 10 times 2 equals 20. What goes in the ones place, Kingston? 0. Now all we have to solve is 36 times 2. Is that a basic fact? Is 36 times 2 a basic fact? So let's solve it over here. Kingston, 6 times 2 is?
12.
Keep the 2 in the ones place, regroup the ones to the tens place. Kingston, 2 times 3 is?
6.
Plus 1.
7.
So that means we put 72 in front of the 0. So 36 times 20 is? 720. Now we have to solve 36 times 4. Is that a basic fact? No. So let's solve it up and down to the side. Make sure you're writing small. Okay, Kingston, multiply the 1. 6 times 4 is?
12.
Class, 6 times 4 is?
64.
2.
Okay, I'm just going to have to pick one person. Come on, this is crazy. This is crazy that you guys don't know your basic facts. Carla, 6 times 4 is?
24.
24. Keep the 4 in the ones place, regroup the 2 to the tens place. It is absolutely, I mean, it is kind of sad that a lot of you don't know your basic facts. And it is not going to go well from here on out. You need to know your basic facts. You needed to know your basic facts like 3 months ago. Okay, now we multiply the tens. Kingston, 4 times 3 is? Class, 4 times 3 is?
12.
12.
12 plus our regroup 2
12.
is? 14. So that means 36 times 4 is? 144. Now, can we leave it like that? No, because now we have to add the answers. We have to add the products together. Do we have to regroup anywhere? No, so we can just add one place at a time. Add the ones. 4 plus 0 is?
4.
Add the tens. 4 plus 2 is?
6.
Add the ones. 1 plus 7 is?
8.
So that means 36 times 24 is?
864.
864. Okay, go ahead. Work on the rest. Go slow. Watch out. Show your work. Do not do this in your head. Zadie, do you show your work for every single problem? Out loud.
Yes.
Mason, do you show your work for every single problem? Cullen, do you show your work for every single problem?
Yes.
Michaela, do you show your work for every single problem? Ethan, do you show your work for every single problem? Kingston, do you show your work for every single problem? Victoria, do you show your work for every single problem? Smith, do you show your work for every single problem?
Yes.
Zari, do you show your work for every single problem?
Yes.
Carla, do you show your work for every single problem?
Yes.
Okay, some of you have had a problem with this, where you're not showing work. Guess what I think you're doing when you don't show your work and you have the right answer? Guess what I automatically think you're doing? Zadie.
Cheating.
Cheating by doing what? What can you use to find the answer right away? Colin?
A calculator.
A calculator. Carla, are you listening right now? If you do not show your work, I'm going to say, oh, that person didn't show their work, but they got the right answer. That means they were using a calculator. That's cheating. 0. Do not turn in a piece of work to me with no work shown. Do you understand? Because then I'm going to think, well, they don't know how to do this in their, they just learned how to do this on paper, so they definitely can't do it in their heads, which means someone either told them the answer or they used a calculator. So you better show your work for every single problem. Okay, go ahead. When the timer goes off, that means you'll have 5 more minutes.